All right, today we're going to talk about Algebra 1, essentially, Chapter 1, Section 1. This should be up later today so that you can come and look for your own and um, and be able to listen to this and hopefully see what we're doing. First of all, the slope of a non-vertical line. Don't forget that the slope is the rise over the run. It's designated by the letter M. It's the change in y over the change in x. Don't forget you got to rise out of bed before you can run in the morning. So you got to subtract the y's over subtract the x's. Just make sure that you subtract consistently. That's a very important formula that we will use consistently throughout the year in AP Calculus. We will use the point slope equation of a line throughout the entire year. Whenever we have a point and a slope for a line, so if we have the slope and a point that it passes through, we will always use this method to find the equation line. Take y minus the y coordinate that's given to you equals the slope times x minus the x coordinate that's given to you. Distribute the slope, add y1 to the other side, and you'll be in slope-intercept form, as you'll see when we go through some of these other pages. Here is the slope-intercept equation of a line. Y equals mx plus b. Don't forget that m stands for the slope, b stands for the y-intercept, which is where the line will cross the y-axis. The slope of a line, get through 2 points. We do the exact same thing when we want to find the equation of a line given 2 points, except we don't know the slope yet. In order to find the slope, we're always going to take the rise over the run. So the change in y over the change in x. Subtract the y's over subtract the x's. That will give you the slope. Leave the slope in fractional form. Do not convert to decimals. Vertical lines have no slope. It's very important that you know that vertical lines have no slope. A horizontal line has a slope of 0. So it's important that you keep those two straight. It will be tested throughout the entire year so that you know the difference between a vertical line and a horizontal line. We should know that from Algebra 1. Went over it in Algebra 1, reviewed it in Geometry, saw it again in Algebra 2, again in Pre-Calc. This is the 5th time that you would have seen all of this material that's in this particular section. For lines that are neither horizontal nor vertical, it's handy to remember the following. Lines are parallel if and only if the slopes are equal. So if we have two lines that are parallel, their slopes must be the same. Lines are perpendicular if and only if the product of their slopes equals -1. Another way to say it is that if slope 2 is the negative reciprocal of slope 1. And here I also tell you that the symbol given here is red if and only if. Lastly, here's a nice summary page that you can refer back to, either through the internet by looking this up, or you have a copy of it in your notes that are given to you at the beginning of the year. A vertical line is always x equals the x coordinate of a point, and a horizontal line through a point is y equals the y coordinate of that point. It's very important that you keep those two straight. It will be tested on the first test. I'll tell you right now. Every year, at least one person misses this simple question just because they're not paying attention to detail. Please make sure that you have this down. X equals the x coordinate is a vertical line through a point. Y equals a y coordinate is a horizontal line through a point. We already talked about the point slope equation. We will use that. I will use it in every single problem that I go over when I have a point and a slope and I want to find the equation of a line. And then we will convert that to slope-intercept form. So make sure you know slope-intercept form. Also, they say in the book that general linear equation is ax plus by equals c. I prefer for you to remember general equation as ax plus by plus c equals 0. This is actually standard form. And this is the form that we put it in when we want to eliminate. If we're solving the equation of two lines, two equations and two unknowns, a system of equations, we generally put it in standard form before we use elimination. One thing to remember about both general and standard form, there should be no fractions, so clear out all fractions when you put it in these two forms, no fractions. And secondly, you need to make sure that A is positive. Try to get used to speaking in terms of mathematical notation. So a way to say A is positive, that is faster, is A is greater than 0. We never want that leading coefficient to be negative. We're going to make it positive every single time. Okay, we're going on. Moving on to the find the slope between 2 points. Also find the slope of the lines that are perpendicular. So for the first part here, to find the slope between 2 lines, we simply subtract the y's or subtract the x's. It doesn't make any difference which point you decide to be x sub 1, y sub 1, and which one you decide to be x sub 2, y sub 2, as long as you're consistent with your subtraction. So negative 2 minus 1 over 1 minus 2. When we subtract, on top we get negative 3, on bottom we get negative 1, which means that the slope is 3. The slope of the perpendicular line then, and a good way to denote that is an upside down capital T to indicate that this is the slope of the line perpendicular to this line, would be the negative reciprocal, the opposite reciprocal. Okay? It's always going to be the opposite sign. If our original slope here was negative 3, this would be positive 1/3. But since we have a slope of 3, this is negative 1/3. Need to be able to find the slope of a line and find the slope of its perpendicular. Moving on to the next example. This, again, will be on the test. Should be the easiest problem on the test. Generally, 95% of the people get it right. Let's see if this is the year that 100% of the people that can get it correct. Find an equation for the vertical line and the horizontal line through a given point. Make sure that you indicate to me which one is which on the test. So in other words, you have to say vertical line. The equation of the vertical line here is x equals 0. It's x equals the x coordinate. The equation of the horizontal line is y equals the y coordinate. That's it. Easiest 2 points on the test. Make sure that we keep it straight so that no one misses it. Example number 3, write an equation for the line that passes through the point P and has a slope m. You will do this numerous times throughout this year in AP Calculus. It is an Algebra 1 problem. The key to it is being able to find that slope if it's not given to you. In this problem, it's given to you. It couldn't be any easier. To find the equation of the line, given a point and a slope, we will always use this formula. I'll write the generic form down for the first one, but then I will not in subsequent examples. Okay? Y minus the y coordinate of the point given equals the slope times x minus the x coordinate of the point given, which is y minus 1 equals 2 times x minus negative 1. Whenever we have minus and negative, don't forget to make this plus a positive. We cannot continue to get tripped up by signs. Then it's a two-step process in order to get it slope-intercept form. Unless otherwise indicated, all equations of lines should be written in slope-intercept form. Distribute the slope. Y minus 1 equals 2x plus 2. Add the constant to the other side. And now we have it in nice slope-intercept form. The slope is 2. The y-intercept is 3. If it asks for it in general form or standard form, in this case, we would simply subtract the 2x to the other side. If we subtract the 2x to the other side, we get negative 2x plus y equals 3. Clear out the negative sign, and we get 2x minus y equals negative 3. This is actually called standard form. To write it in general form, we simply need to add the negative 3 to the other side. So if we wrote it as 2x minus y plus 3 equals 0, this would be general form. Notice, no fractions, Leading coefficient is positive in both cases. The 2 before the x is positive in both cases. Standard and general form, both must be the x term, then the y term, then we deal with the constant, either keeping it on the right side or moving it over with the x and the y term. Okay? So there's a little summary on all of that. 7. Find the equation line passing through the 2 points. Once again, the key here is how do we find the slope? Many of the problems throughout this year when we're trying to write the equational line will simply be about how can we locate the slope. Given 2 points, it's easy to find the slope if you know the slope formula. And everything we do first semester will be based off this slope formula. Once we learn about derivatives, it's going to be based off this slope formula. Make sure you know it. Subtract the y's. 1 minus negative 2 over subtract the x's. Negative 2 minus 2. Notice this time I chose the first point to be x sub 2 and y sub 2. It doesn't matter. As long as you're consistent subtracting, you'll be fine. Okay, minus a negative. Don't forget to make it plus a positive in this case. So we have a positive 3 on top and a negative 4 on the bottom. We want to find the equation of the line. Now I can pick either one of the 2 points that are given. I'm going to select the first point here. I use my slope, which is negative 3/4, and the point negative 2, 1. And we plug it in point slope form. Y minus the y coordinate equals the slope times x minus the x coordinate. Notice, if we would have selected the other point, our line would look slightly different here because we would be using the point 2 and negative 2. And you can leave it in point slope form on the AP test for the free response, which is fine. But the key is make sure that we're converting to slope intercept form on all tests. So this becomes plus a positive. We will distribute. When you distribute, we have to be masters of fractions by the time we reach calculus. When we distribute this negative 3/4 to 2, we have to reduce the 2 and the 4. And a negative times a positive is going to be negative 3/2. Okay. So we get negative 3/4 x, and we're going to get a minus 3/2. Very important that you can reduce fractions quickly in your head. The majority of the AP test is no calculator is available. That means none at all to do addition, subtraction, multiplication, and division. We have to know how to use it for the calculator portion, but less than half of the test can you even use a calculator. So we have to have great computation skills. Add 1 to both sides. If we add 1 to both sides to get y by itself, we get negative 3/4 x. Negative 3/2 plus 2 over 2 is a negative 1/2. That's slope intercept form. The slope being negative 3/4 because that's the coefficient of x. The y-intercept being the point 0, negative 1/2. This is a great problem to look at how we convert it to either general or standard form because we have a fraction here. And the fact that we have a fraction, the very first thing that we have to do is clear out the fraction. We clear out fractions by simply multiplying every term by the lowest common denominator. The lowest common denominator here is 4. So if I multiply the first term by 4, I get 4y. If I multiply the x term by 4, the 4 just cancels, and we get a negative 3x. If I multiply negative 1/2 by 4, I get a minus 2. Now I can add the 3x to the other side. And here is the equation in standard form. Occasionally on the test, I will ask you to convert some equations to standard form or general form. If you want general form, add the 2 to the other side and set it equal to 0. This would be general form. There is a difference between general form and standard form. So it is important to know the difference, particularly if you're talking about the distance from a point to a line formula. It must be in general form in order to use the distance from a point to a line formula. I'll talk about that particular formula in class when we go over this. Example 5, write the equation for a line with the given slope and y-intercept. Draw a complete graph. It doesn't get any better than this. To find the equation of a line, given a slope and the y-intercept, is simply y equals 1x plus the square root of 2. Now, if the coefficient is 1, we typically don't write it. It's an assumed 1. So just write y equals x plus the square root of 2. That easy. We could convert this if we wanted. We could subtract the x to the other side, get rid of the negative sign to put it in standard form, and then we could subtract the square root of 2 over if we wanted. We'll just leave this one in slope-intercept form. The reason why I ask you to graph this is because we have to get used to numbers in calculus that aren't necessarily rational numbers. So when we want to graph something like y equals x plus the square root of 2, we can still do this. The slope is 1. To write as a fraction is 1 over 1. The y-intercept is the point 0 comma square root of 2. So if we mark this out, the square root of 2, we should know approximately what the square root of 2 is. You can look it up on your calculator if you need to, but we know that the square root of 2 is about 1.414. The square root of 3 is about 1.7. So the square root of 2 is about 1.414. We just approximate that the best that we can, and our slope is up 1 over 1 from there. So we count up 1 and go over 1. We count up 1 and go over 1. We go down 1, back 1, and then we sketch this line in. So there are a few sketches like this that they're going to expect you to do. Something like this on your paper is good enough. But I want you to get used to sketching lines in which we're dealing with irrational numbers. A square root that is not a perfect square is called an irrational number. Okay? Example number 9. Parallel and perpendicular lines. Write an equation for the line through P that is parallel to L and then perpendicular to L. To find parallel to L, the first thing we have to do is find what is the slope of L. In order to do that, we have to get the y term, the y variable by itself. Subtract x to the other side. There's your 4. Divide everything by 2. 4 divided by 2 is 2. So in this particular, for this particular line, we have a slope of negative 1/2. The y-intercept is positive 2, but we don't really need that right now. It's nothing that we're going to use in order to find the equation of the line that is parallel. We have a slope of negative 1/2. Okay? We know that goes through this point right here. 1, 2. So to find the parallel line, it's y minus the y-coordinate of the point that is given equals the slope, which is negative 1/2, times x minus the x-coordinate of the point that was given. Distribute the slope. A negative times a negative is a positive 1/2. Add the 2 to the other side. Don't make it 2.5. Make sure you write it as an improper fraction. When you add 2 to the other side, 2 plus 1/2 is 4 halves, plus 1/2 is 5 halves. That is the equation of a line that is parallel. And please make sure that you tell me that this is the parallel line. Okay? It has the same slope. Again, we could convert this by multiplying everything by 2 and adding the x term to the other side to get it in standard form. subtract the 5 over after that if we wanted to. Okay, I'm not going to convert every one, but you should be able to easily convert, and it should not be a problem at this point in mathematics. Okay, let's find the perpendicular. The key to the perpendicular is that the slope of the perpendicular line is the opposite reciprocal of this slope right here. So we need to flip it and negate it, which makes it a positive 2. Then you must walk through the same process again. Many students want to just use that slope and then just use the same y-intercept of the parallel line. You cannot do that. You have to walk through the entire process again. Y minus the y coordinate equals the slope times x minus the x coordinate. Distribute the 2, distribute the slope, add the negative 2 to the other side. Negative 2 plus positive 2 is 0. That is okay. Don't be surprised when you get equations of lines that look like this. This is the perpendicular line. The perpendicular line has a slope of 2 and a y-intercept of 0. If we wanted standard form, we would subtract the 2x to the other side and then clear out the negative sign. Or we could subtract the y to the other side. So 2x minus y would be standard form. 2x minus y equals 0 would be the standard form. And in that case, the standard form is the same as the general form because we do not have a constant term. So make sure you do know how to convert anything to standard or general form. If you have any questions about that, you're going to need to see me individually. But that's something that I expect everyone should be able to do by the time that they are in calculus. Here is the assignment, the very first assignment. It's page 22. I think there might be an error on that. Let me get it fixed right now. So we have this change for everybody. The numbers are correct, but the page number actually should be, in the new version of the book, it begins on page 7. So it will be page 7 through 9, essentially. So I'll just put page 7 up here for this one. It is page 7. Okay? Same problems. 2, 6, 10, 12 through 38 evens, and 44. I'm trying to give you a nice selection of problems without making you do a bunch of mundane work that you already know how to do. But this is a very important lesson. I can't stress it enough. It's really the start of everything that we're going to do in calculus. Starts with these equations of lines and really slope. The whole first semester is about slopes and how we can determine the slopes of functions. Okay, I hope everybody takes the time to look at this and help you get through this first lesson. And this lesson is going to be due the very next day, which is going to be on Friday. All right? Hope this works out all year long, being able to do some of these, and look forward to seeing you all in class.